Good morning, learner. Welcome to my YouTube channel. Today we're going to learn about osmosis. Osmosis is a process by which water molecules move from a region of low concentration to a region of high concentration across a semi-permeable membrane. It is one of the processes by which substances move in and out of the cell, and it always requires a semi-permeable membrane. So, to demonstrate osmosis in living tissues, in the first picture, you can see inside the potato cavity there is sugar solution, which is hypertonic to the colored water in the beaker. So, and according to our definition down there, a hypertonic solution is a solution that is more concentrated than another solution, while a hypotonic solution is a solution that is less concentrated than another solution. And water molecules move from a hypotonic solution to a hypertonic solution. So in our setup, the sugar solution is hypertonic and the colored water is hypotonic. So the water will move from the colored water through the potato tissues and into the potato cavity, thus causing the water level to rise, as you can see in the second picture. Next, we are going to learn about the factors that affect osmosis, and they are five: the thickness of the membrane, the surface area to volume ratio, pressure, concentration gradient, and temperature. The first factor is thickness of the membrane. A thick membrane slows down the rate of osmosis, while a thin membrane increases the rate of osmosis. This is because in a thick membrane, molecules move through a longer distance, while in a thin membrane, molecules move through a shorter distance. The next factor is surface area to volume ratio. As you can see in the picture, there are three cubes. The first one measures 1 centimeter and the surface area is 6 square centimeters. The volume is 1 cubic centimeters. So the surface area to volume ratio is 6:1. In the second cube, it measures 2 centimeters. The surface area is 24 square centimeters. The volume is 8 cubic centimeters, and the surface area to volume ratio is 3:1. In the last cube, which measures 3 centimeters, has a surface area of 54 square centimeters, a volume of 27 cubic centimeters, and the surface area to volume ratio is 2:1. So the higher the surface area to volume ratio, the higher the rate of osmosis, and the lower the surface area to volume ratio, the lower the rate of osmosis. And small organisms have a large or a higher surface area than large organisms. The next factor is pressure. Osmotic pressure is a driving force in osmosis. When a solution is under high pressure, or rather under a higher pressure, it can push water molecules through the membrane more effectively, and increased pressure can counteract the natural flow of water, as you can see in the picture above. The next factor is concentration gradient. Concentration gradient is the difference in concentration between two regions. The higher the concentration gradient, the higher the rate of osmosis. And the lower the concentration gradient, the lower the rate of osmosis. And as osmosis is going on, the concentration gradient decreases, thus slowing down the rate of osmosis. The last factor is temperature. An increase in temperature increases the kinetic energy of the molecules, thus increasing the rate of osmosis, and a decrease in temperature decreases the kinetic energy of the molecules, thus decreasing the rate of osmosis.